Hey guys, hi and welcome to the video. My name is Somil Shah, and in this video, I'm gonna be walking you over the code base for a simple Flask API, and essentially I'm gonna be showing you horizontal pod autoscaling, which means as the CPU utilization increases above 50%, automatically add more pods. As the CPU utilization goes down, reduce the number of pods. This is absolutely fantastic because in the night times usually the load is pretty low, right? Which is why you don't want to have enough pods, right? In the daytime when the load is high, you want to have enough pods, right? This is an amazing feature of Kubernetes that you could scale number of pods based on essentially several metrics such as CPU, request per second, and a lot more, right? So this video, I'll be walking you over the code base and followed by a very beautiful demo. So let's get started. So if you are on my screen, this entire code base is on the GitHub as well, so you don't need to worry. I have following files: app.py, which is where my Flask app is, deployment, Docker Compose YAML, Docker file, matrix server.yaml, requirements, run shell, and wsgi.ini. So going into it one by one. So here, if you observe, I have a hello function that performs a square root of a number, randomly takes a number and performs a square root, right? Then I have a deployment, then I have a Docker file. So essentially I'll go over the Docker file from Triangulo, WSGI, Python 3. This is essentially, I'm creating a work directory called app, copying all the files into the current directory and running my pip install requirements.txt. After that, if you want to test things out, I have a simple compose file which will essentially build your Docker image, right? So a very simple compose file. I think this should be like this. Okay. So a very simple compose file that you can use to test your microservices, right? Once you're done with that, now you want to essentially do a production ready test, right? You want to scale up, scale down based on demands, right? So here is where the matrix server comes into place. So the matrix server will essentially aggregate all the information such as CPU, memory, and all the other vital information that you need to know, right? So that's my matrix servers.yaml file. Then I have my requirements.txt where I have my libraries that I'm about to use in this project. After that, the main file here is the deployment.yaml file, which is where all the magic happens, right? So if you observe carefully, I have a deployment, right? And based on the theory, we know that a deployment essentially has a replica set. Replica set has a pod as containers, right? Each node can have several pods. Each pod can has a container, right? So here I define my deployments, right? And then essentially in the specs, I'm saying, I'm giving it a name right here. And the strategy is rolling updates, right? So whenever I commit it, it's gonna roll the updates, right? So that's the strategy that I'm trying to follow here. Then the specs, essentially the name of my Docker container, the image, right? Then I'm providing the port and then a liveliness probe. Remember, there are three types of probes: liveliness, readiness, and startup probes. I'm using liveliness probes to make sure my pods are healthy, and because this essentially allows you to make sure that whenever a pod enters into deadlock, the probe will detect that and essentially it will kill the pod and it will restart the new pod essentially. Here I'm defining the resource limit, for example CPU and the memory, how much I need. After that, I have a service file. This is essentially my load balancer that's gonna load balance it. And then I made my essentially horizontal pod autoscaler, which means based on I'm providing a target utilization as 50%. I could provide multiple minimum replicas, maximum replicas, and what I want to scale, right? Now, the entire code base is there, as I said, right? So I want to show you a demo, right? This is absolutely phenomenal to me because this is just amazing, because when I see this, I'm like, wow, like whoever designed all these stuff has done a fantastic job. It's just an appreciation towards the technology. So as you can see, I have one pod right now which is running, right? Hopefully I don't have the CPU stats, but I have one pod here. Okay, so I'll show you right here, and then I have a JMeter test, right? So here is my JMeter test, right? I'm gonna make 100 requests per second. So this is gonna create, a lot of requests, and the CPU is gonna spike up, and I should see automatically pods being added. So now what you see here is, as you can see, number of requests has been increasing, and it's doing an infinite loop, right? And soon here you'll see after 5 to 15 seconds, you'll see number of pods have been scaled up. And we can also test that through a command line. So I can say kubectl I can say kubectl get HPA, and here you can see I have 137%. My threshold was 50%. At this point, as you can see, automatically it did added those pods for me, right? Now I just want to stop the test essentially. So as you can see, this is absolutely phenomenal, guys. I don't know, but this is just really amazing to me. When I see this, I'm like, wow. It automatically adds pod, it does the health check there, and if anything goes wrong, it's gonna kill the pod, it's gonna spin up a new one. As I said, right, this is absolutely phenomenal. The entire code base is there in the description section. You can see the CPU stats and all the other metrics, right? Just waiting for my camera to start up again. So this is great, right? Absolutely great. Kubernetes is a very vast topic. There's a lot to learn. There are people who are essentially doing multi-AZ architecture with Kubernetes. There's just a lot to do. We haven't even touched the surface of EKS on AWS. So when we go to the cloud, we'll see how things work, how to attach a domain name, and all these amazing, beautiful stuff, right? Then also there are tools, for example, Prometheus, Grafana to monitor your essentially Kubernetes matrix, right? You could do that. Then essentially there are people who have developed Elasticsearch aggregator. So all your logs from the Kubernetes are essentially pushed to Elasticsearch using Logstash. There are just phenomenal things happening in the world of Kubernetes, containers. It's just amazing. So what I wanted to show you is a glimpse, right, on how you can easily scale up any of your Python projects, right? Either it be a Flask, a Django, or any other projects. What I've also seen while watching a lot of videos, people essentially creating microservices. For example, let's say you have a product, right? So product, then you have a credits. I'm just making up, okay? So instead of making everything in one API, right, and having microservices, what these people do is essentially they'll have a product, essentially a microservice working on port, let's say 20. Then catalog product, just making up, okay? Credits, essentially microservices working on port 21, then 22. So they have multiple microservices working on different port. Then they dump a Swagger UI where you can drop down and select the exact microservice that you want, and you can invoke it. Behind the scene, it's gonna invoke a Kubernetes. It's gonna scale up, scale down automatically. It's just fantastic, right? All right, that's it for this video. I'll leave the entire code base on my GitHub, so kindly check that out. And if you have any more questions on Kubernetes, let me know. And as I said, guys, I am myself a beginner. I'm not an expert on Kubernetes, but I am exploring, I'm learning, I'm enjoying, exploring more and more on Kubernetes, right? So my suggestion to you, if you want to do this, actually clone the repository that I have. This is going to be a lab 5, and actually run this, okay? Until and unless you do it, you're not gonna get the concept. You're not gonna because then it just ends up like a copy paste. What you're gonna do is you're gonna try to Google stuff when you have errors, and you're just gonna copy paste blindly without understanding what's going on. Try small parts. For example, the way I approach it was, first I just created a pod, right? Then I essentially said, okay, you know what? Let me add a health check. Let me add secrets. So I went slowly, not everything in once, right? That is exactly what I'm trying to show you. I hope you enjoyed the video and the contents, and the code base is in the description section below. So do check that out. And if you have any more questions, list your question in the comments and we can go from there. Thank you so much for watching. I'll see you in the next video.